Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at dataengineeringpodcast.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your data pipelines or trying out the tools you hear about on the show. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. You can help support the show by checking out the Patreon page, which is linked from the site. Your host is Tobias Macy, and today I'm interviewing Yoni Iny about Upsolver, a data lake platform that lets developers integrate and analyze streaming data with ease. So, Yoni, could you start by introducing yourself?
Hi, Tobias. Yeah, I'd be happy to. So I'm Yoni. I'm the CTO of Upsolver. I started Upsolver in 2014, and we've been building a data lake platform since around end of 2015, beginning of 2016. Originally, I started, I learned how to program in the Israeli army, and yeah, I've been doing that ever since.
And do you remember how you first got involved in the area of data management?
Yeah, so I guess, the Army uses tons of data. And I mean, every time I worked with data, I mean, basically all my projects were data projects. And then every time I worked with data in the Army and after, I think 90% of the work was getting it into a usable state. And then 10% of the work was getting insights out of the data. So I think it was kind of like a natural progression. Like, you build the same data management system again and again and again for each project, and then eventually you're like, why are we doing this each time? Why don't we have just a system that does it for us? So yeah, I think that was the motivation.
And so, can you give a bit of an overview about what Upsolver is, both as a platform and a business, and how it first got started?
Yeah, Upsolver we bill it as a data lake platform. And basically the idea is that if you're using a data lake, you should really be using Upsolver, or let's say Upsolver or an equivalent system to manage your data. And I mean, basically it started because, we were actually in advertising. That was the space, like the company, actually, it was a product company. And we decided to build a data lake because we had huge amounts of data, and we spent, I think, like literally 90% of our effort was around managing the data, and it really slowed down development. I think there are a lot of tools out there that help, especially open source tools. There's the Spark and Kafka and all these tools that help you get like work with the data, but it's very ad hoc. You need to really put everything together. So yeah, you're basically repeating the same work over and over again. So I think that, like, once we realize that we're putting in so much effort, like so much of the company is based on actually just managing the data, and together with, let's say, our like desires of building interesting software products. So yeah, so we decided to go in that direction.
And what are your overall goals for the platform, and what you're hoping to solve for people who are choosing it as their platform of choice for a data lake?
So I think, data lake, like the data lake itself, is a pretty new concept. And right now it's still at the level where people are kind of debating, is it good? Is it bad? Like, should I actually be using a data lake? And I strongly believe that, except for a few edge cases, data is going to be moving into data lakes. And then I would say I would just want Upsolver to be the like de facto standard data lake platform. I mean, basically, I just want people to stop suffering their data, and start enjoying it, which is something that's very hard to do at the moment. So yeah, I think that's where I would want Upsolver to be.
And as you mentioned, there are still a lot of discussions about whether or not data lakes make sense in terms of being the platform for people's data, or if people should be using data warehouses or some other solution. So I'm curious what your thoughts are on when data lakes are the right choice for a platform, and whether you think that they should be the primary component or simply used as one stage of the overall life cycle of the data, and that it should ultimately end up in a data warehouse.
Yeah, so I mean, first of all, I think data lake isn't like well defined at the moment. I think a lot of people have different opinions of what a data lake is. So when I'm talking about a data lake, I'm talking about a system that raw data is coming into. So it's your first and a half step within your data pipeline is going to be the data lake, and that on top of the data lake you have a lot of data discovery and data management. So you're getting value out of the data lake. I think a lot of people think of a data lake as as just kind of a place to put your data, and then we'll figure it out later. And I really don't think, like, obviously when you think about it that way, it's not very valuable. Like maybe you'll get value later, but building something for some unknown objective isn't great. So really, like, the idea, at least when I think about a data lake, is that you want to be getting a lot of services out of it. I mean, when you're talking, okay, so why would I want a data lake? Like, why am I not happy with my database, or with Excel for that matter? So, they talk about the three V's. You have data, velocity, variety, and volume. So, I mean, I think really mostly, even if you have one of those V's, you're probably going to want to go in the direction of a data lake. So if you have a large volume of data, then like the cheap storage really makes a huge difference. I mean, a data lake is basically, you're going to be paying for compressed data on blob storage. So you're paying roughly $20 per month per terabyte. I mean, that's the cost of compressed data. Whereas, I mean, you'll easily pay 10 times as much in any alternative, basically. Like there isn't any alternative that isn't going to have the data on hard drives that are costing you a lot more, and multiple replicas, et cetera, et cetera. So that would be volume. And then velocity is kind of similar. I mean, with velocity comes volume. If you have tons of events coming in all the time, then obviously you're just going to have a lot of data in general. But aside from that, also data that's changing very, very quickly tends to be very challenging for non-data lake systems. So you're going to be spending a lot of effort kind of just managing your data, which again is not what you want to do. I mean, most people have a business that's a real business. You want to get something out of the data, but you don't want to be coddling it all the time. And then the third thing is data variety. So you have a lot of different data sources, you have a lot of different types of data, and with a database, or with any data management system, which is like, first I do the management and then I get value. So you're going to be doing a lot of extra work. A lot of the data just isn't that interesting, so you're never going to be touching it. And just figuring out kind of like what the schema is, and how I should be looking at it, how I should pivot it. I mean, that's a lot of stuff that you don't even necessarily know ahead of time. So I think also, even if you have low data volume, but you have high data variety, you might want to use a data lake, just so that you can, you have a place where you can dump all your data and right away see, what is it? How am I supposed to work with it? Things like that.
And one of the difficulties of data lakes in particular, because of what you're mentioning of variety of data or changing data, is being able to manage the schema to be able to ensure that you're able to analyze the information once it lands. So what are some of the ways that you approach that challenge of being able to ensure that the information that gets stored into the data lake is ultimately useful, and that you're not just writing out a bunch of records that don't have any sort of common format or common schema that will just end up causing greater pain down the road, rather than doing any sort of upfront verification before it ends up getting written to disk?
Yeah, so I think that's a pretty common problem, that like, often data is coming from like sources that you don't even control. So you have a Kafka stream, it's coming from mobile devices in the world, and some of them just send garbage, basically. So some of it isn't even parsable, some of it is in completely the wrong schema, your streams get mixed up. I mean, these things happen in the real world. So I mean, I think the tooling is super important there, and Upsolver, like, that's basically what we're focusing on, is giving you visibility into messy data. So the first thing, obvious or not obviously, but the first thing is that you don't want to discard any data. I mean, if it's a single record that doesn't pass validation, okay, that kind of makes sense to discard, but you don't know that ahead of time. Often you're going to have kind of a stream of data, and suddenly it shifts because someone released a new version, and all your data is of the new schema that doesn't pass validation. And then, I mean, are you just going to discard your entire data stream until you fix it? I mean, that's awful. So I think the most important thing, first of all, is just to get the data in there. So you don't want to do any validation as you're ingesting data. You want to make sure that everything is stored properly, everything is visible. And then from there, you want to do your data cleanup within the data lake. I mean, that's really the paradigm that we're promoting, that data comes in, it's stored in your object storage, and then you run cleanup ETL operations, which are going to filter out records that aren't interesting, or split a single stream into multiple streams according to that. So yeah, I think basically, like, I mean, the difficulty is the insufficient tooling, is once the data is in, I have to be able to see it. And Upsolver goes a long way into helping you do that. And obviously, without being able to see what your data is, Data Lake doesn't really add much. I mean, the data's there, but I don't know if it's broken or not. I'm going to find out anyways in the downstream systems. So, but if it gives you the services that I can see how many things don't pass validation within the Data Lake, that I can run the ETLs and clean it up within the Data Lake itself, then I'm saving a lot of work.
And what are some of the overall shortcomings of data lakes as a platform and some of the challenges that are unique to that particular approach?
So I think of a data lake as, as similar to a database. It's kind of like a database with a different, paradigm, but it's supposed to give you pretty much the same value, like cheaper, bigger, etc. But aside from that, so I think the main shortcoming is just that there's very little in the space now. Like you have Spark that lets you, and Presto and Apache Drill and things like that let you query the data, but there isn't anything that's really like, they're all open source tools, which are great, but there isn't anything that kind of pulls it all together. So I think generally the main shortcoming, I think that's going to disappear in a few years. Especially obviously with Upsolver, but also, I'm sure there's going to be a lot of competition that's doing similar things, and the cloud services themselves, Amazon and Microsoft and Google are going to be adding a lot more features around that to support it directly. But yeah, I think it's just very immature right now. So you don't have a lot of tools that just run on top of the data lake and give you value. Maybe the other thing is that if you have small data, like if you have a data set that's just like static, I have a few million records and I wanna munge that, then I think data lakes, like, they do tend to bring in some overhead. And as opposed to databases or Excel, which are really good for that, data lakes, they're built thinking about large streaming data. So if your data isn't large streaming data, then possibly you're going to be making effort to fit it into that square, which, like, if it's round data, then maybe you better off use like different tools. So I think it does depend on the type of data also that you're using.
And so for the Upsolver platform itself, can you describe the overall architecture and the major components of how it's put together for people to be able to manage these large volumes and variety and velocities of data?
Yeah, I'd be happy to. So first of all, Upsolver runs in the cloud. Let's say not exclusively, but it definitely is much happier there. So the first thing is that you're talking about, like, usually you're talking about huge amounts of data. So like you have to be very, very cost efficient. So the first thing is that the entire architecture is headless, just to make it easier to scale and easier to manage. And the whole thing runs on Spot instances, or the equivalent of Spot instances in the different clouds. Again, just to save money, since we're using object storage as just the central repository, S3 in Amazon, blob storage in Azure, etc. So all the data is really cheap, but you want to make sure that also the processing is as cheap as possible on these volumes of data. So that's, basically anywhere where we could cut costs relative to the amount of data, that's what we chose to do, and that, like, kind of shows in the architecture at each step. I mentioned that object storage is where we store data. So that's, like, it's really kind of like a basic tenet of the entire architecture. Anything we do is going to be stored within your object storage. There isn't any, like, repository on the side or anything like that. So all your data is stored in a single place, and all of your ancillary services are also based on that. So again, like, saving money, and also simplicity, because everything's in the same place. Scheduling in Upsolver is a first-class citizen. It's basically, I would even say, like, the scheduling is the top level thing that then everything is built around of, because you have data coming in all the time. And I think it's usually the other way around in open source big data projects, where you start with writing your scripts, your ETLs, and then you figure out how to schedule them with an external system. And I think that leaves a lot of efficiency on the table. When you start with the scheduling, then you have a lot more power as far as as far as dependencies between tasks and just making everything a lot more seamless. So that's a big thing for Upsolver. And I think, I mean, not like the last thing, but kind of even maybe the biggest thing is how we index data within the data lake. So basically, we have a proprietary object called a materialized view. It's basically a file format of data stored in the data lake, but that lets us query large amounts of data in real time. So I think very similar to the architecture of key value stores like Cassandra or Redis, but built directly on top of object storage instead of using local storage for it. I mean, object storage is super fast, really, and it got much faster in the last even year, I would say. So you're not paying a penalty for that at all, but it can scale much better. So I think when you combine that with everything else, that's what really gives you kind of the visibility into your data that you really need.
And one of the things that you mentioned in there that I find particularly interesting is the use of spot instances as a cost mitigation strategy, which makes sense in terms of the pricing, but it also introduces a lot of challenge and complexity in terms of being able to ensure that you're able to deploy and scale these instances quickly and consistently, as well as that given the fact that you're processing these data sets, there is a certain amount of statefulness to the computation. So I'm curious how you manage the cases where spot instances get removed in the middle of processing, ensuring that you don't end up just dropping those tasks and being able to pick back up where you left off.
Yeah, so I mean, basically, the whole architecture is pretty much in order to make sure that you can preempt an instance without losing anything. So first of all, the headless architecture is a big part of it. So basically, any server is just a worker, kind of similar to a Spark worker, but then you don't have the master server that would kind of need to be a non-spot instance. So you just don't have that. And then all of the work that our system does is from object storage to object storage. So you have kind of a well-defined chunk of work that you need to do, and it starts from one or many blobs and ends with one or many blobs. And since that's like kind of a well-defined unit of work, any server can do it. Multiple servers could do it at the same time if there's like a split brain syndrome or something like that, and like nothing bad is going to happen. It's not going to break anything. So once you have that, basically like a server can die, and so some other server is going to pick up instead and do the work for it. So basically it becomes a question of latency, which is super important, by the way. It's not like the fact that a server can go down in the middle of a computation. You definitely want to make sure that you're not introducing a 5 minute or a 10-minute lag in the processing of the data. I mean, a lot of our customers use Upsolver for serving real-time data. So they're actually trying to, like, they want the data to be as fresh as possible, and definitely adding a few minutes is out of the question. So there is a lot of complexity there, but I think that's like kind of dwarfed by the complexity that would be if you could actually have data correctness issues that would happen if a server suddenly falls in the middle.
And another piece that you mentioned is that you have your own specific data format for being able to store the information in object storage. So I'm curious at what point the data is transformed into that format and how it compares to some of the open source options such as Avro or Parquet or Orc files.
Yeah. So, I mean, first of all, to be clear, the data lake itself is stored in either Avro or Parquet, and is in a like it's completely open. You can read it with any external system you want. These indexes are used specifically for either just gathering metadata on the data itself, or else if you specifically build it because you want it for a use case, for example, like doing aggregations on your data or things like that. So it's an additional service on top of the data, which is in an open format. And I mean, this like our materialized view format, I would compare it most to the SS tables of Cassandra. So I mean, basically, it's a key value store format. It's a file which, I mean, the purpose is to kind of load it into memory and then answer get by key request. I mean, if you think about, for example, Upsolver's UI, which given a data stream, you can see all the different fields and all the different kind of top values and the percentage of that value within the field distribution. So it's a lot of get by key requests, and I think that's like kind of a majority even of operational workloads are going to be something like that. So, and that's what, for example, Cassandra or Redis would do. So the purpose of the file format is to fill that niche, and then like if I'm talking about the difference between our file format and Cassandra, which would be, well, I mean, you could also compare it to Parquet, I think, but Parquet is a columnar format, so it's more for scanning a file rather than getting a specific row. But we are kind of leaning on the same principles that you want your data to be as compressed as possible, and columnar formats are very, very good at compressing because data tends to be similar to other data within the same column, but not similar to other columns. So one of the things we did within this format is, while we are storing it as a row-based format, so you can deserialize a single row instead of needing to look up each and every column value, we are compressing it per column. So we're using an arithmetic coding tokenization. But basically, the purpose is that we want to get the maximum compression for each value, but within a row. So there are a few things that you can't really do, like run length encoding, which is kind of very common in columnar formats. And then we're basically trying to mitigate those issues with a very powerful compression. And basically that, like, what it lets you do is store a lot of data in a relatively small file in object storage, and then when you load that into memory, you can just hold it there as is. Whereas alternative formats like the Cassandra SS files, they're actually decompressed when loaded into memory. So the server can only hold in memory like a factor of 10 less than would be otherwise possible if it was stored compressed.
And so the fact that you keep the source data in that Avro or Parquet or whichever other file format, I think is definitely valuable to the end user because it enables them to use whatever other processing or analysis or extraction tools they want to use for other purposes beyond what they're doing with Upsolver, while at the same time being able to take advantage of the optimizations that you're doing with your file format, which sounds to me as though it's in some ways more of the metadata layer of being able to track the catalog of what data you have and what schemas are available without having to go all the way back to the source files every time to be able to introspect what schemas are there, where it's stored, what sort of partitioning strategies are being used, etc.
Yeah, totally. I mean, you really nailed the like the differentiation. So, I mean, yeah, there often I just want to see what's in the data. I want to open the stream and say, like, this field, what are actually the values? Did I ever see anyone with to be deleted equals true in this stream? Like, I want to just know what the contents of my data is, and then asking that question of the raw data can often, like, it's a process, it's work. I want to just see it. It's a simple question. Give me the simple answer right away. So for that, yeah, you have, like, that's the kind of metadata catalog level, and I'd say that's step 1.5 to step 2 of data process. But then you actually have the your systems. You have, like, I want to actually put some view of this data into a database because my website uses it, or I want to transform it into a data set to run machine learning, or I want to create a report on top of that. So all these, either I'm going to use Spark or any other tool that just takes this data and processes it and does whatever and outputs it somewhere. Or I would use Upsolver as a tool that does an ETL, takes the data, transforms it, aggregates it, etc., and outputs it to a table or to some other down the stream system. But yeah, like, it's whatever tool is the best at that point. But definitely you're going to want to at least be able to see your data and make sure that it's all managed, it's being retained properly, and it's in kind of a consistent format that you're not going to have, like, surprises down the road.
And as we mentioned earlier, one of the challenges of data lakes is being able to manage schema consistency and schema validation at the ingestion point. So I'm curious what strategies you're using for validating the schema of the files as they come in, and how you handle records that don't match a specified schema for whatever particular reason, while still being able to ensure that you're not just throwing data away arbitrarily because of of some sort of bug at some step in the pipeline?
Yeah, so I mean, I'm going to divide data into two buckets. You have self-describing data and non-self-describing data. So I think data in the wild is actually at this point, it's like 90% JSON files. So that's self-describing, and then like you can basically ingest the data. It's I mean, as long as it's a valid JSON, but you can basically ingest the data regardless what's in it, and it'll be fine. On the other side, you have Avro, for example, if you're using it per record instead of as a closed file, or CSVs without headers, protobuf, all these formats that aren't actually self-describing. You need to have an external schema. And those are a lot trickier because you could actually have, I mean, we have a customer that has Avro data, and their schema evolved, and the old schema obviously couldn't read the new data and vice versa. And so basically just everything crashes. And so the way we deal with those situations is that we basically divide our ingestion into two steps. The first is taking the data from wherever it is, like often Kafka or Kinesis or something like that, and just copying it into object storage as is. So basically not doing anything, just making sure that it's going to persist, at least until it's finished parsing. And then the parsing of the data takes it from the original format and basically builds the data lake. So creates Avro files or Parquet files, depending how you configured it, and just but everything has to pass validation at that point. So it has to be legal data. I'm not checking that the fields are correct, just checking that I actually know how to read it. And anything that doesn't pass validation is put aside, and you get like alerts in the UI and stuff like that, so that you can know, okay, there was a problem, and then you have tooling to allow you to change kind of if it's just a matter of schema evolution, for example, you can say, okay, this is actually the new schema, and then re-ingest the broken data. So basically, let's say that's only relevant for situations where you have data that isn't self-describing. So when data is self-describing, it's going to go in anyways. You're going to see the data, and then often what you're going to see is that in the last 5 minutes, suddenly this new field appeared, or this field that I count on, it's suddenly not there because it changed name or something like that. And that's usually something you're going to find out at your very down the stream system. Suddenly I have my web app and it hasn't received data in the last 5 minutes because I don't know why. The data's just gone. So that's basically a situation where your schema evolved or changed, or your data changed in a way that you didn't expect, and then it breaks your ETLs and eventually your end system. And then what you want is the tooling to basically look at all the steps going backwards until you can see what the root cause is, and then correct it in retrospect. And that's really kind of what the data lake is meant to do, because you can get visibility into all of your data at any time scale and drill down as much as you want. So you can see, okay, like the problem started at this minute, and this is what the data looked like before, this is what it looked like after, and then you can change the ETLs. And since it's all stored in the data lake, you can also change the ETLs retroactively. You can say, from the point where the data changed or a bit before, now I'm going to do that, do the new transformation kind of. So yeah, I think that's like, if I summarize that, I would say that use schema on read if at all possible, like if your data is self-describing, and kind of try to move all of the validation and transformations down the funnel to places where you have full visibility into the data.
And that brought up another topic that I want to dig into in a couple of minutes in terms of monitoring and alerting on the data as it's flowing in. But before we get to that, I would also curious how the overall architecture of Upsolver itself has changed over the time that you've been working on it from when you started to where it is now. And if you were to start over today, anything that you would do differently without having the weight of legacy?
It's a good question. I think the major change that's happened is that we've become a lot more cloud specific. When we started out, we were kind of saying, okay, object storage is the central repository of everything. So obviously we need to support S3 and Google Cloud Storage and Azure Blob Storage, and that's it. And then we're completely cloud portable. You just switch out the storage and everything else runs the same. And I think over time we realized that first of all, there are a ton of very, very valuable services that each different cloud provides. And also there are a lot of gotchas and things that don't exactly work the same between clouds. So I think slowly, where we started in a completely cloud agnostic way, and I could have said, yeah, sure, we support all clouds, but in reality, we kind of supported none of them. And if I look, let's say, at our Amazon deployment now, we use CloudWatch, we use CloudFormation, we use Kinesis, EC2 with spot instances, Elastic IPs, ALB. Like we're using, I don't know, like 8 to 10 different Amazon specific products that like they're not portable at all. They're just systems within Amazon, but they make the system so much more robust that it's really worth it. And also seamless integrations, like someone new who wants to start using our system, there's a whole DevOps process that is completely avoided of getting permissions and spinning up servers, creating a VPC, all these things that you need to, like, you could have a sheet of to-dos with like 12 bullets, or you have just a single CloudFormation script. He clicks create, and that's it, and you're up. So like having the seamless integration into the cloud, I think it's a huge barrier of entry. It means you don't actually need a DevOps person to manage your data, which is huge. It's like a complete paradigm shift. So yeah, I think that's like just integrating more deeply within each different cloud platform was a big change, and something we probably started too late. Like we probably should have started there of saying, okay, we'll support Amazon in the beginning and then move on to the other clouds. And instead we were kind of like, let's be cloud agnostic. And then we had to shift in that direction.
And so now going back to the question of monitoring and alerting on the data as it's flowing in, I'm wondering what systems or strategies you're using to enable that, and some of the common problems that might occur, or some of the more challenging aspects of being able to provide that to users of Upsolver.
Yeah, so I think monitoring systems have started consolidating slowly. I mean, common ones that we would see are Prometheus or CloudWatch, Datadog, InfluxDB. So I mean, there are a few others, but in general, you have let's say 5 to 10 common monitoring players, and they all look pretty much the same. So I think in that sense, the world has become a lot easier, that instead of everyone rolling their own monitoring, you have kind of very common interfaces. So it becomes very easy for a system like us to integrate directly into the customer's monitoring and alerting systems, that they're already getting alerts from there. So you don't have to add an additional layer of complexity. And then as far as issues with the data itself, I think the two most common issues are either that data changes and then ETLs fail. So basically, I depend on a field called event type, and the lowercase t became an uppercase T because some developer thought that makes more sense, which is probably true, and that breaks the system going from there downwards. And I think the second most common is just that one of the systems in the pipeline breaks. So suddenly like data isn't arriving in Kafka anymore. Like it's an empty stream and we don't know why. So I think in both cases, the most important thing is to know about this as quickly as possible. And invariably, you're going to know about it first from the downstream system. Like in the end, I have a database that I care about, that I want to make sure is getting data all the time. And that's where I'm going to feel it the most. But since the data lake is the step in the middle, it can be an early warning. Like it can know before the downstream system that something's happening. But yeah, I think the most important thing there is to be able to rapidly fix these problems. First of all, it's early discovery, but also being able to quickly, I mean, correcting your data, obviously, like taking the uppercase T and changing it back to the lowercase t, but also then taking the data that exists that's broken and doing a very quick transformation to get it in, to be able to use it. And you don't want that to take a week of development, because these things happen all the time. You want it to be a few minutes. It's also usually a simple fix. So I think that's kind of the biggest added value of having Upsolver or a data lake in general in the middle of that pipeline. More in the corrective measures than in the alerting itself. But obviously, yes, like, all the different metrics of data arriving, what the velocity is, how many events, etc., like what's actually happening, that all you can get out of the data lake directly.
And so the sort of major components of the lifecycle of data in a data lake platform, or an Upsolver in particular, are the ingestion, the storage and management, and then the egress of the data from that platform. So I'm curious what you have found to be some of the biggest challenges at each of those major stages of the life cycle of the data as it's working its way through the data lake?
Yeah, so I think in all cases, right, they're actually all very challenging if you're doing it yourself, because then you have to do everything for each individual stream, and you have to decide on a format for each individual object. But then let's say if you're using a data lake platform, then in ingestion, I think the most challenging thing is usually going to be actually managing the Kafka. And I've actually seen a lot of customers starting with Kafka and then migrating to Kinesis or Azure Event Hub, just because you don't have to manage it. Like Kafka is a super robust system, but it can sometimes break for strange reasons. So that, I guess, to a certain extent, also just managing permissions between the different systems, making sure everything is kind of secure, but at the same time you do have access, and you don't accidentally lose permissions, which then also would cause data to stop streaming. So I think that's as far as the data ingestion. Then in the object storage, I mean, really it's it's a lot of decisions. There isn't anything technically difficult about putting data in a Parquet file on S3, or at least for the most part, because there are actually also several different formats of Parquet, and some of them work with Spark, some of them work with Presto, etc. But there are a lot of decisions to be made. You have to decide like what the folder structure is going to be, what the file format's going to be, what type of compression you're going to use, kind of what's the largest file size before you want to split it into several files, and how are you going to discover all these new files that you created. So I think that's like, if you're building a data lake yourself, like I really wouldn't recommend that. I would say that's kind of similar to saying, I'll decide to use Oracle because it's an amazing database, but I won't use their storage layer. I'll build the Oracle files myself. I feel like that's kind of the level of the comparison there of kind of rolling your own storage layer. But yeah, I think it's mostly making the decisions of like kind of the right decisions that are going to scale, and that you're not going to regret them down the road. And changing that is very, very difficult once a system exists. And then getting the data out. So data is usually like, when you think about data, you usually, the examples are always flat. It's always like, we think of data as databases. And maybe in 5 years that won't be the case anymore. But for now, like when people think about data, they think of CSV files. But that isn't data. Data is hierarchical always. 90% of it is JSON. So you have a schema that has records, and within the records, additional records and arrays that might have nulls in them and might have all sorts of different stuff in them that so like there's a lot of variety, but also like the tools of transforming data are either SQL, which works very well on flat data but doesn't really support hierarchical data at all, or else writing code. And writing code really sucks. I mean, you have bugs, and like you want a declarative language. There's a reason SQL is so popular. So I think that's another, like when you're talking about tra- getting the data out of the data lake, like taking this data, and often your output is going to actually be a flat format, or just a key value. Like I want to know for each user how many times I saw them. Super simple, the output, but the transformations you have to do on hierarchical data are really challenging. And that's something that we specifically address in Upsolver. Kind of the reason we chose not to go with SQL as the language of our transformations, but also just adding a lot of support, a lot of native support of hierarchical data, and what happens when you do a transformation on a nested field and you bring the field out to an unnested field. So all these things kind of happen seamlessly, and that I think is a huge challenge. Like if you already had flat data and you're transforming it to a different flat format, that's usually not going to be too challenging. But if you had a nested format, then that can be quite difficult. And as far as outputs, I think maybe the most common output we see today within Amazon is Athena. Athena is a system that basically it wraps. It's a managed Presto, and Presto is a SQL engine over S3. So basically, it lets you query lots of files, and you get results in seconds. So you can query like terabytes of data and get results really in a few seconds. And I mean, that's, let's say, the most common output from Upsolver, because people just want SQL on top of data, usually for analytics or reporting, things like that. And there, I think The main challenge is managing the metadata of the output itself, and that's something that we also try to do in Upsolver. So, like, I think, I mean, maybe it's a bit beyond the boundaries of what the data lake platform should be doing. I mean, it's more the responsibility of the downstream system, but since it doesn't do that, so then we kind of added that service. But I think then if you're talking about downstream systems, getting data into a downstream system is usually not too challenging. Replaying a large amount of historical data into a downstream system, that can be very challenging. So often systems that you use in order to actually build your product on top of, they usually have limited throughput. They're usually like, I'm a database and I can get up to 5,000 records per second, or I'm a data warehouse and I can get up to 100,000 records per second. But if I have 100 billion records of backlog, and I want to just, I want to change my transformation, put all of it into there, I think that can be very challenging. I think that's probably the main driver of why a lot of our customers are choosing to use Athena, is because the data itself is stored in S3. So you really don't need to, like, you can transform as much data as you want. It has limitless throughput. So I think that's really a main driver for the adoption of that product.
And one of the things that you mentioned there is that for a lot of the data lakes that are built in-house or self-managed or put together from various open source components are using SQL as the layer for being able to do transformations or processing of the data once it's landed on the file system, but that you have your own interface for being able to natively support these hierarchical data structures. So wondering if you can talk a bit about what the workflow looks like for somebody who's using Upsolver and the types of user that you're targeting with your platform and how that compares to some of these self-managed or self-hosted data lake systems.
I think when you're looking at a self-managed data lake system, I mean, the target audience is almost invariably going to be a big data engineer. So it's someone who knows about big data, who's very familiar with the challenges of kind of running all these systems in a distributed and high throughput environment. And then, the tools of choice are usually going to be Spark, where you're going to be doing, let's say, a certain percentage SQL and then a certain percentage just coding kind of, or using systems like Pandas or something like that in order to manage your data. But I mean, the end user, the person who actually needs the data, I mean, the big data engineer, their role is to make the data accessible to the data analysts, data scientists, or developers who are actually going to be building stuff on top of it. So in Upsolver, we're kind of trying to cut out the middleman in a way. So I think our target audience is going to be people who don't know much about big data, but do know a lot about their data, or want to know a lot about their data. So it's going to be either developers, data analysts, or data scientists, and kind of trying to give tools to those people that their expertise is much more around what they're building than managing the data that's going to feed it. I think for 2 out of 3, probably SQL is definitely the language of choice. And I think it was, let's say it was a kind of a statement for us to say we're not going to be SQL. Like, Confluent, the company that manages Kafka, came out with KSQL, which is like SQL over streaming data. So they really went in that direction. And when we saw that, we were like, well, did we actually make a mistake not going with a SQL interface? And definitely it is a barrier of entry, because people know SQL and it's very fluent to them to just start writing their code, and it kind of does what they expect. I mean, obviously you can't translate SQL from one engine to another really, but it more or less does what they expect. And so that would be for data scientists and data analysts. I mean, that's their bread and butter. That's what they know how to use. And I think we have a good offering in that sense, because it's very visual, kind of even lowering the barrier of entry a bit more to people who SQL isn't their first language, let's say. So for them, I mean, having a visual interface, I'd say more similar even to Excel than anything else. I mean, Excel is something you can really, like, a layperson who hasn't worked with Excel can more or less just start working with it without like too much introduction. So I think that's kind of the direction we're going, getting like an immediate feedback loop to the operations you're doing and having everything work in a lot more of a visual way on top of your data. And I think for developers, definitely it's incredible. because I mean, developers, they're used to writing code. They're used to like, I mean, their tooling was awful, and then having this kind of visual representation where you can also build things with kind of a code-like interface is amazing for them. And mostly developers weren't like, there aren't many developers whose first language is SQL, let's say. So they're kind of replacing a second language with a different second language that's much more expressive for what they're trying to do. So for that user, I think it's very valuable.
And have you found there to be a particular scale or level of data maturity for an organization at which point they would be better served by moving their data lake platform to be fully managed in-house and built on top of their own tooling, or pulling together some of the open source options as opposed to using Upsolver? Or do you think that Upsolver solves the majority use case regardless of scale or maturity of the organization?
Well, I mean, at like Facebook scale, they would probably have their own Upsolver that they built internally. So, I mean, but like if I'm taking aside the companies that are actually building a data lake platform themselves also, I think that most companies, like, or any company would get value out of having Upsolver at least as the first step. So, I mean, it could be that you have a lot of data infrastructure that's already running on top of your data, and you don't want to migrate that. But on the other hand, you do want to get insights, and you want to be able to see your data immediately as it streams in. So I think in that sense, even if you're not doing a full-on migration, if you're not like saying, okay, Upsolver is going to be my data lake and all my data lake services are there, but adding it as a step between your streaming data and all the operations you're doing right now, I think that adds a lot of value. Yeah, I think that it's definitely more challenging for us when you have a blue ocean, when a company doesn't really have data infrastructure yet. They have a lot of data and they want to use it, but they don't necessarily know how. I mean, that's definitely the easiest situation for us to add a lot of value. Whereas if you have a company that has a lot of data infrastructure that a lot of people are managing, and a lot of existing ETLs that are kind of legacy and difficult to maintain, but they need to be maintained and they need to be transferred over. I think that's a lot more challenging. But I don't think that it's the size of the company so much. I mean, even a very large company with tons of data and tons of big data engineers, etc., I think will get a lot of value out of using Upsolver. But I do think that depending on how much legacy infrastructure you have, that can add complexity to any kind of migration or adding another system in the middle that changes anything. Like usually these systems, like you change a comma somewhere and everything just completely crashes. So you have to be very careful, and that's I think a big barrier to entry.
And so, looking forward, what are some of the major features or improvements that you have planned for the future of Upsolver that you're most excited by?
Yeah, so I mean, well, where to start? I think most of it would be around lowering the barrier of entry. I feel like Upsolver gives a ton of value to people who are actually who are using it on a day-to-day basis. But kind of getting the word out there, getting new people to try it out, and having it kind of like just experiencing it is kind of the main hurdle, I would say. So definitely, as far as the platform itself, I would definitely want to see more like high-level primitives. So like supporting, I mean, today we support joins, for example, between data streams, but not as a primitive. You have to build the join yourself, and adding, let's say, a joined stream between two streams, I think would be very valuable to reduce complexity. So I mean, that kind of thing is something that I'm personally excited about. But I think that the thing that's really going to drive adoption the most is better cloud integrations. It's already pretty good, but the better it is, kind of the less steps you have integrating, the happier people are going to be to try to do it. And just in general, lowering the barrier of entry, adding SQL as an alternative to our language is something we're working on, and I'm very excited about. Not because I think that SQL is the right language to do these things, but I do think that it's just the language people know. So giving them the opportunity to adopt or to try out Upsolver without needing to learn something new is very, very valuable. But yeah, it's basically getting the word out there. I think it's super valuable. Like I think it's people who have used our system versus after having done data project, not even necessarily big data project, but data projects before that. They're like, I would never work at an organization that doesn't use a system like this, because it's like you're just like underground kind of. You're trying to dig your way out. So yeah, it's super exciting.
And so, with that, I'll have you add your preferred contact information to the show notes for anybody who wants to follow the work that you're doing and stay up to date with the work that Upsolver's working on. And so, as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I mean, I think the biggest gap is just that, I mean, there isn't really a consolidated platform yet, but you have to build everything from disparate tools. So you're really kind of like, yeah, I mean, it's a project. Any data management, I mean, if you're not using Upsolver, of course. So any data management or any data project, let's say, is actually a project. It's not like a data task. It's a data project, and I definitely see that kind of consolidating in the next few years. Like, I think that even putting aside Upsolver, which I obviously hope that we're going to be leaders in the space and etc., but I think you're also going to see a lot of companies starting to even just package different open source tools together, like Spark together with Spark Streaming, together with Airflow or Flink, or like taking a bunch of these different tools today that exist, and kind of if you patch them together, they're going to do what you want, and selling it as a single unified product. So I think that's it. I think it's just having everything communicate with each other without needing to specifically manage each component.
All right. Well, thank you very much for taking the time today to discuss the work that you're doing with Upsolver and some of the, as you said, whys and wherefores behind data lakes in general. So I appreciate that. And I look forward to seeing the work you continue doing with Upsolver. And I just want to say thank you, and I hope you enjoy the rest of your day.
Thank you very much. It was my pleasure.